Hi everyone, this is Q again. Today's lecture is training number 6. Okay, let's take a look at the main importance. Rotation, understanding set distance. Okay, first of all, there's no datum B, but let's take a look at the datum A first, which is the top surface of the part for leveling. And datum C, which is a circle for translation. And if you look at here, 40 basic dimensions on X and Y each axis for the circle of diameter 10. And for those basic dimensions, they can be a feature for rotation in this drawing. So we're going to learn how to do the offset distance for rotation. Okay, let's take a look at this example first. They're the same part, but the right one is more rotated than the left one. So in these two cases, the left one's X and Y value could be almost the same proposition, but the right part's X and Y value for the smaller circle would be a little different than the left one, because the proposition is different and the X value would be smaller and then the Y value would be longer than the left part, because the right part rotation is not constrained. So to do the rotation for this part, the basic dimension, which indicated as a 40, would be the reference. So let's learn how to do the offset distance, and let's take a look at the practice. So first, measure plane for leveling. As you can see, the part is a little rotated than the 3D model on the NeuroMeasure actually. So then you can see the comparison for the rotation. So click alignment and then click leveling. And measure circle for datum C. Click alignment and translation. And then you can see the difference between PCS and actual part, because there's no rotation is constrained. So now I'm going to measure the hole of diameter 10. So you can see the X and Y values here. The proposition is quite different. So to do the offset distance, click alignment, rotate, and offset distance. And this window will pop up, and input nominal on X and Y as 40, and then click OK. And PCS is rotated as 16.875 degrees. Now let's recall the circle 2. Now you can see the circle 2's value, X and Y, same as 40.002, because nominal value 40 were the same per position. That's why the same values for the each axis. So this was the 2 axis offset distance. But let me show also it can be done with only 1 axis offset distance as well. So go back to the alignment, so rotate and offset distance, and this time I'm gonna input only 40 on x-axis and delete completely for the y input value. And click OK. Now it rotates again, but the degree of rotation is slightly different than previous way. Now let's recall the circle 2, and then you can see the result for the x and y value, and you can see the x value is exactly 40 because I only put nominal for x-axis. So that's why the y value is 40.004. So this method is constraining only 1 axis offset distance. So that's it for the training number 6, and I'll be back with you guys in the next video. Thanks for watching.